Okay, so I'm going to ask you to draw some graphs of a ball being tossed in the air. So first of all, you need to know that it's going to be the height of the ball dependent on time. So as time passes, the ball goes up and comes back down. Okay? So which one of those lines is going to be time and which one of them is going to be height, do you think?
This one will be time and that one will be height.
Okay, can you label them time and height? And how do you know that that one's time and this one's height?
Because the bottom line is usually the independent variable.
Okay. Okay, so if I throw a ball in the air, can you sketch a graph of what the height of the ball will look like as time goes on?
What?
I'm going to throw a ball. I want you to sketch a graph as time passes. What's going to happen to the height of the ball? What would that graph look like?
It's going to go like up and down.
Okay, sketch what you think it would look like. Okay, so why did you start here?
Because that's like no time, no height.
No time, no height. Okay. And so what does this mean?
That's how high it will be when it's been after it's left your hand for that amount of time.
Okay. So what if I threw the ball with more force initially? Like if I threw it up in the air harder, how would this graph look different?
It's gonna go higher faster.
Okay, well sketch what you think it would look like. Okay. So what does that gap tell you?
That it stayed in the air longer.
Okay, stayed in the air a little bit longer. What if I started recording time before I actually threw the ball? Then what would happen to that graph?
Would be like
So-
stretched sideways more.
Well, I don't know. So I say go, and I throw the ball up in the air, and it comes back down again. Where would the graph be then? Where would this shape be on there?
Oh, it'd be moved over.
Okay, so sketch where you think it would be.
Like how long? Like
I don't know. Just pick some random time. Doesn't matter. Okay. So you made that one end at the same time. What does that mean?
that the amount of that you waited the same amount of time that it took the ball extra on the time you threw it harder.
It took the same amount of
So
time.
like the time you waited before you threw the ball was the same amount of time that the second throw had more than the first.
Okay. I have to think about that one for a minute. What would happen if I stood on the chair when I threw the ball?
The height would start a little bit.
Okay, so sketch what the graph would look like if I was standing on a chair. Okay. Last one. Instead of, before I go to throw the ball, I accidentally drop it, and then I catch it again. What would that look like? Okay, good.